Hi everyone, this is VRL and today we will learn to do linear regression in Excel with 6 different methods. First, we will do manual linear regression, then we will use solver, then we will use the regression tool in Excel in data analysis toolpack, then we will use the trend line in Excel graphic, and we will use LINEST formula. And the sixth method, we will use the mathematical equation to solve our problem. Let's get started. First of all, I want you to understand that it's fundamental that you understand linear regression. By understanding it, you can develop predictive models, explore data, identify important relationships between variables, and make accurate predictions and conclusions. So, let's see in short what is linear regression. We want to predict an outcome based on existing data. For example, here we have years experience and salary. We have this graph, and we want to have a trend line by an equation. So if we have, for example, 15 years here, we want to know what would be the salary. So to get this result, y, we have to first find the intercept, the b, and the slope, the m. So the first method for solving this equation will be the manual one. Here we have the data and we do a scatter chart. Okay, insert. And now we can make a manual line to try and understand. Sorry, I have to copy only the line. And now we want to understand where it is the intercept. Okay, we see that it is around 30,000 and we put here 30,000. Okay, and now we want to understand the slope. Okay, I put here the line, horizontal line, and the vertical one. So the slope, if you remember from the mathematics class, is the difference between y2 and y1. Okay, the difference between the vertical dimension and divided by the difference between the horizontal dimension. Okay, so as you see here, it's y2 minus y1 divided by x2 minus x1. Okay, if we do this manually, let's see which is y2. So y2 is around 100,000 and y1 is around 63. Let's see. Okay, and on the horizontal axis we have from 4 to 8. So our slope would be this formula. Okay, 100,000 minus 63 divided by 8 minus 4. Okay, and our result is this. Okay, and we put here the slope. Okay, and now we can construct this equation. We say it here in this column, estimated salary is the intercept, okay, J1 plus the year, okay, multiplied by the slope J2. Okay, and we have this. Okay, we have this, and we see that we have some differences, which are the errors. Okay, we will see how we estimate the accuracy. We have here the squared error, and here we have the sum of the squared errors. Okay, we approximated this estimation, but now we can do it exactly. So we will use the solver. Okay, we put back the values from the manual trial. Okay. And now we want to see what are the optimum intercept and slope. So we go to data, to solver. Okay, and we already have it here. So the objective is J4. The objective is the sum of the square errors to be minimum. Okay, meaning that our estimation would be as close as possible with the real figures. So the objective of solver would be J4 sum of square errors minimum. Okay, by changing variable cells J1 and J2, this. Okay, and we do not check here make unconstrained variables non-negative, and we will use this GRG non-linear. Okay, and we press solve, and solver gave us the solution. So with these two figures for intercept and slope, we have the optimum. Now we can calculate a decrease in the error versus the manual one. Okay, because in manual we had this huge error, and now the error is lower. So this is the decrease. And then we can calculate the variation of this decrease. Okay, we say decrease in error from solver divided by the manual. Okay, how much in percentage the error decrease? It's 25%. So we explained from the manual one 25% of the estimation. This is called R squared, and we will see that in Excel regression we have this calculated here. And now I showed you how it is actually calculated and what is its meaning. Actually, we can calculate the decrease in error versus the average, because the first estimation and the basic one would be to use the average. Okay, so we have here the average salary, and we calculate the error versus the average. Okay, we make the difference between the average and the real salary, and then we square the error. So we see that we have this huge sum of square errors, because the average in this case is not a good estimate. And actually the R squared we calculate again from our solver solution, which is the optimum. We calculate versus the average what is the decrease in error. So this 21 billions minus this almost 1 billion, so the decrease is 20 billions, and the R squared is the variation of the decrease, so the difference. Okay, the difference divided by the sum of square areas from the average, and we have this is actually the R squared 95% that you will see here. We will have in Excel regression tour calculation. So this means that 95% of the estimation is covered with this optimum solution compared with the lowest estimation, the average one. Okay, so now you see how we can do this with solver, uh, starting from the manual one. Now, the third way of doing this regression is with the Excel regression tool. So I will hide this. Actually, I will insert more columns. Okay, and we will go to data analysis, and we go to regression. And here in regression, we say input y range, the range with the output. Okay, this is the salary. Input x range, the year's experience. We have the labels because we selected them. Okay, and that's all. We will put it here in the output range. Okay, and say like this. So Excel calculated, as you see here, the adjusted R squared that we already calculated manually. And also it calculated the intercept, okay, 25792, that we already have it from the solver, okay? So Excel gave us the same solution and the same slope, okay? So we have here the intercept and the slope, and we can calculate here the estimated salary. And if, for example, we want to see for 20 years of experience what would be the salary, we use this formula with the intercept and the slope. Okay, so let's go to the fourth way of calculating the linear regression in Excel. The way we do it is like this. We select the data, we add a scatter chart, okay, and now we have some options. We add the trend line linear, okay, so we have this trend line, but we also have trend line option, display equation on chart, and display R squared. And you see that Excel gives us the intercept and the slope and also the R squared. So we take it from here and we calculate here the equation, okay, intercept plus slope multiplied by year, and we have the outcome for 20 years, for example, or for 15 years we have this 167. Okay, the fifth way of doing linear regression is with the LINEST formula. So LINEST is an array function. It will create a row where it gives us the slope and the intercept. Okay, so what we have to do is to select, for example, we want to show only the slope and intercept. We select the cells where we want to put them, and then we write LINEST, okay, known wise, here the known output, known x years of experience. And now because it is an array formula, we not press enter but control shift enter. Okay, so now as you can see, Excel put some curly brackets here because it's an array formula, and it gives us the slope and the intercept. Okay, so now we have all the data needed to construct our equation. And the sixth way of doing this linear regression is with the mathematical formula, because actually in statistics some clever mathematicians already calculated how is the m, the slope, and how is the b, the intercept. Okay, so we have these formulas, and here I have calculated the parameters. Okay, n is the count, is the number of variables, and then we have this sum of y, okay, sum of x squared, and so on, sum of x, sum of xy, okay, and then we just put this formula with these parameters, the formula for slope and for the intercept, okay, and we get the same result as in LINEST, Trendline, Excel regression, and Solver. So these are the 6 ways in which you can do linear regression in Excel. I hope you enjoyed this video. Please like and subscribe. Thank you.